Greetings and welcome once again to my new calculus channel. My name is John Gabriel. And so, uh, once again, I'm going to go over these details of my closed form trigonometric formulas for the ratios because I was asked to do it again in order to explain this simply. All right, so now, look at this diagram down here. Okay, you've got an angle here, okay? And this angle here is in degrees. It's 44.1 whatever degrees, right? So there it's 90 degrees and here it's 0 degrees, right? Okay, and normally you can work with, in your mainstream mathematics, you can work with degrees or radians. That's okay. But there's a much easier way to do trigonometry, and that's using radical units. So, what are radical units? So, what is the difference between a radical unit angle and a degree or radian angle? Very simple, simply this. So, you can get all these angles here in terms of this line segment, okay? In terms of this line segment. Do you see that? So, this length here of the radical angle is just the length of this blue line segment. So, here it's 0, here it's uh, square root 2 divided by 2. And here it's square root 2, right? The total line segment. So all the angles from 0 to 90, and that's all you really need because you can get all the others with the trigonometric identities, and they work exactly the same way as your bullshit mainstream trigonometry, okay? So this is the way you can do trigonometry in a very simple way without degrees or radians. And so this angle here is this length here. Now, from this length, we obtain what's called a parameter because all the Gabriel formulas, which are closed forms, by the way, look at this. This is closed forms. Closed form. It's x over the square root of 1 minus 2x plus 2x squared. And sine x of Newton's formula is a finite sum plus an ellipsis following it. So it's never accurate, but mine is completely accurate. It's finite. It's done in a finite number of steps. Okay, whereas with Newton, you have to basically check how accurate it is because every time you add another term, you get more accuracy. Okay, so now um, the way to do this is you take this length, this blue length, okay, which is the radical angle length. To get the parameter, you square it, divide it by 2, and take the root of that. And so why do you do that? Let me explain to you why you do that. So let me get my pen out here. Okay. So now, the reason you do that is due to the fact that at any time, if you draw a perpendicular here like that, oh my goodness, can't anything work properly? Let's just undo that there. And I don't know why it's, there you go, back to that. So if you take a line like that and a line like that, these lines are always equal. Okay, so basically what you're saying is I'm going to find the length of either of these, and it's always going to be a parameter to any of the trigonometric ratios, to sine, cosine, etc., because you're treating this as 90 degrees. So you have this parameter from which you can find this length and that length, okay? And you've got all the ratios. And of course, everything is explained for you in here. Now, notice there is no direct conversion from radical angle units to degrees or radians or vice versa, but I've given you conversion formulas and they're all in this document, okay? And of course, in the same document, I give you all the formulas, right, for use radical angle units in which x is the parameter. Okay, so from your radical angle unit, you always get a parameter because they all take the same parameter. Does that make sense? Okay, so that's pretty much how radical angle units work. If you've got any questions, ask one question at a time in the detail section keep your comments to yourself. I'm generally not interested in what most of you have to say, unless you're genuinely interested in writing a comment that makes sense. But most people don't really have any intelligence, or not certainly not intelligence compared to mine. But anyway, so the sine of the angle of this angle here is given by these values, and notice that I get the same value that who knows how many terms you need to take in sine series to get the same thing as the brilliant Gabriel closed form formula, right? So that's for approximately 24 degrees. That's for 56, etc. And if you don't believe me, let's do a little test, okay? So we're saying that we want the sine of that. So we could say 49.1, doesn't matter whether you do it in 49.1, doesn't matter whether you do it in degrees or radians. 992743533. It doesn't really matter how far you go. I'm just doing this for the fun of it. And then you just say trigonometry, and once I press sine, I should get the same as these values, right? Oops, there we go. I do. You see that? So, identical. There it is. Very well. If you're not already a subscriber, become a subscriber. Tell your friends about my channel. Follow me on academia.edu, because on here I've written many brilliant articles. Okay. Over 253 papers, one book. They're all free. You can download them for free. And tell your friends about this, and, reach into your pockets. Instead of wasting your money on coffee or whatever it is, save up and contribute at the link I'll provide in the details section. I'm the great John Gabriel, and this is the New Calculus channel. Till next time, goodbye.